Hello students, welcome back. In the last class, we have seen the Fourier series of square wave can be written in this manner, where you have these sin x, sin 3x, sin 5x. These all are odd harmonics. So this is the first harmonics. So if your omega value is 1, or you say that if your function, say your function is say sin x, you have y equal to sin nx. Now if your n is equal to 1, and then you have a time period 2 pi, and this is called first harmonic or fundamental harmonic. Similarly, if you have a n equal to 2, then here your period will become pi, and this will be your second harmonic. Similarly, sin 3x is the third harmonic, sin 5x is the 5 harmonic. So the square wave contains only your odd harmonics, and this is the magnitude. So if I see the magnitude of each harmonics, so I can write this is the magnitude of each harmonic. First harmonic has the magnitude 4 upon pi, and this is my sine curve, sin x curve, shown with a black color. And your f3, okay, f3 has the amplitude 4 by 3 pi, and this is shown here by violet color. And fifth harmonic, you see the amplitude is decreasing, 5x, shown by green. Pi means between minus pi to pi you have a 5 cycles. So you have 1 2 3 4 5, total 5 cycles. You have 7 means f7. F7 is shown by the orange color, and 7 means you have a 7 cycles, 1 2 3 4 5 6 7 cycles between the range minus pi to pi. Now what happens if I add these harmonics? So as we see, if I add these harmonics, I got this curve, this red curve, summation of these things, and this is my original square wave shown with a blue color. And as I'm keep on adding the harmonics, it's approximating my square wave. So if the number increases, it will be almost completely, this red curve will completely become like your square wave. So this is your Fourier series, where you can approximate or you can write any periodic function in the form of infinite series of sine or cos x. Here we have only sine. Some function requires only cos, and some will be there will be function which have both sine and cosine terms. Now the next is Dirichlet conditions. So which function can be written in the form of Fourier series? So there are some conditions that you can represent a periodic function by Fourier series, and those conditions are: first thing, your function should be finite, single valued, and it should be periodic. Okay, it should be periodic. And the second is that function should have a finite discontinuity. So that means your function should not be infinite in that interval. So function should have a finite discontinuities, and a number of finite discontinuities also should be finite. That means your fx and fx should have a most finite number of finite discontinuities. That means the function is your should be piecewise continuous. Okay, piecewise continuous means you see here your function here, this is the discontinuous, okay, discontinuity, but this is the finite discontinuity. Finite means you don't have an infinite here values. This is nowhere in the interval function is becoming infinite. And you see x is equal to 0, the function goes here is a 1 and minus 1 1. Similarly, your discontinuity discontinuity at minus pi, you have discontinuity at minus 2 pi. So you have a finite number of discontinuities, and the amount of discontinuity is also finite. Okay, similarly, your function should be integrable. Integrable means it's a value in the interval should be finite if I integrate this function, and it should have a finite number of maxima and minima. Okay, it should have a finite number of maxima and minima. And now let us see these functions. So question says, if the following functions are defined of the interval and the functions are periodic, so this already they told the functions are periodic. So whether or not each function can be represented by a Fourier series. अब इसमें से कौन कौन सा फंक्शन Fourier सीरीज से रिप्रेजेंट हो सकता है? So number one is your x cube. So x cube क्या है? X cube is your this can be represented by Fourier series because this is the finite in the interval. Okay, finite and periodicity already given. Similarly, now next function is your 4. So this is yes. This is also polynomial. This is the finite in the interval, single valued, and periodicity already given. Nowhere it is becoming infinite. So this can be represented by a Fourier series. Now here function is infinite. Okay, discontinuity, infinite discontinuity, infinite discontinuity at x is equal to 0. So this function cannot be represented by Fourier series. Similarly, you have x minus 5. Now this function is become infinite at x is equal to 5, but x is equal to 5 is not in this interval. Okay, so these intervals I am writing here, the intervals are for all the function pi to pi, and plus they are periodic in the range 2 pi. So this can, because this discontinuity is out of the is not inside the interval, so this can be expanded with a Fourier series. This has a discontinuity. Okay, at t equal to x is equal to pi by 2. There is an infinite discontinuity. So this cannot be expanded using Fourier series. And now you have a question 6. Okay, now this here you have x square plus y square, so pi square minus pi square. So now here you have xy has the double values. Okay, so this is not a single valued function. Okay, if I want to write x, that will be plus minus pi square minus y square, root pi square minus y square. So this is a two valued function, two valued. So this also cannot be expanded using the Fourier series. So in this way, you can identify which function is can be written as an infinite series. Now say the next topic is finding the sum of Fourier series at a point of discontinuity. Okay, so the function is discontinued at minus 2 pi, minus pi, 0, pi, and 2 pi. How to find the value of the function at these discontinuities? Because if I approach 0 from the left, okay, so it's just slightly before 0, the value of the function is 1. So if I write fx minus 0, the value is 1. And if I go slightly above or beyond 0, that means we approach from the right, my function has the value 1. So now in order to write the function value at discontinuity, we need to take the average. Okay, for example, here minus 1 1. Okay, the average of the function is 0 at this discontinuity. Similarly, at other points also you can write. So whenever we need to require the value of the function at discontinuity, we need to take the averages. Okay, and now next is your odd and even functions. Okay, so what is odd and even functions? So we know, so this makes Fourier series simplified if our function is odd or even. So if function is called even, if I take f minus x is equal to fx, so this is for even function. And for odd function, we know if I take f, I replace x with minus x, this should be equal to minus of fx. Okay, that means now if you see this curve, okay, this curve is my fx is equal to x square. Okay, this is fx is equal to x square. Now this function is symmetric with respect to y-axis. If I put f is equal to minus x, this is again equal to x square. So this is example of even function. Now we see this is function. This function is the cos fx is equal to, this function is fx is equal to say cos x, and this function is also an even function because your fx is cos x. If I take f equal to minus x, we know the cos minus theta is cos theta. So this function is equal to fx. So this function is also your even. Okay, if I go to the next, say if I write now the next function, this function is again, if I write say this is my fx, and if I define, and the interval is all the function I'm showing, the interval is minus pi to pi. So this function I can represent as fx is equal to pi minus x in the interval 0 to pi. You have an interval 0 to pi. Okay, so at x is equal to 0, this function is pi, and x is equal to pi, this function is 0. Similarly, this function also can be written as a pi plus x between minus pi to 0 in this interval. If I put 0, still is giving f pi pi. If I put minus pi, this is giving 0. So this is the representation. Now this function is also even. You can clearly see the both side of the y-axis, the function is same. That is symmetric. Function is symmetric with respect to y is equal to y-axis. So now you can check it also. If I put f equal to minus x here, what will become? This will become pi plus x, and this become minus pi, and this will become pi minus x, and this will become minus pi x. I'm replacing with minus x. This becomes 0. Now you have, again I'm writing fx is equal to pi plus x. Now this is a minus, I want to make it x, so I have to multiply with minus 1. When you multiply with minus 1, the inequality sign will change, so this will become 0 x pi. That means between 0 to pi, the function is pi plus x. Okay, minus 1 I'm multiplying, minus 1 I'm multiplying. Similarly, I've multiplied this one also, this value is pi minus x, and if I multiply by this minus 1, so this become pi x 0. Okay, so this is equal to, this is same like 0 x pi, and this is, so here I have multiplied. So this we have this should go minus pi. So minus pi means minus pi to 0, minus pi to 0. This is your pi plus x, and from 0 to minus 0 to pi, you have pi minus x. So this is also equal to function fx. This way you can check it whether function is a even or odd. So this is the even function. Now let us go to the next one. So this sine wave, this is the odd function, okay? Because you take any value of x, fx is equal to minus fx, you can clearly see, okay? So this function we have already defined. How to define this function? This function already we can write fx is equal to, this function is value is 1 when x is between 0 to pi, and this function value is minus 1 when you have a function between value is minus pi to 0, okay? Now if you replace f with minus x, what will become? This remains 1, this becomes 0 minus x pi, and this become minus 1 minus pi minus x 0. Now f minus x is equal to, here multiply by this minus 1, so this will become 0 x minus pi, okay? And similarly I am multiplying, so minus pi to 0, okay? You to multiply with full minus 1, okay? And similarly we apply here with minus 1, so this become plus 1, minus will apply, so this become pi x 0. So 0 to pi you have 1, and minus pi to 0 minus 1, this is nothing, this is same like your f equal to x, okay? Similarly here last one also we have to check, okay? Here also this frame you have to check it again. So here what we have done, this is my f minus x, this become plus x pi minus x, okay? Now I multiply this with minus 1, okay? So what will happen if I multiply this with a minus 1, this become minus pi. If interval I'm multiplying, what is happening interval minus pi, so this will become 0 plus x pi, okay? So this should be minus pi minus x, okay? And if I multiply it all with minus 1, so this I already replaced, so this I need not to multiply this one. Only this inequality if I want to change from minus, here already it is changed. So if I change the inequality, this becomes 0, remains 0, x, and this become minus pi. So minus pi to this become pi plus x. This is correct. And here minus 1, if it is plus 0, so this is also correct. What's the issue now here? Now if you go here back, this function. So here minus x, so you have, this is, if I keep it 1 only, and this is a minus 1 only, and then if you minus here multiply, so this becomes 0 x minus pi, this should become minus 1, okay? It should become minus 1, okay? And now this is your remains minus 1 here. So now so this is now minus fx, okay? This is minus fx, fx minus equal to minus fx, this is the odd function. This is not equal to fx, this is equal to minus fx, so this is the odd function. Now next is So this is also an example of a odd function. Okay, if I write y equal to or fx is equal to x. Okay, so this is the a odd function. Similarly, you have now if you have a function which is combination of odd or even. Okay, if you have two functions which are even, you multiply that function will become even. If you have odd, that become even. If you have odd even, that function become even. Let us see some questions. Identify odd and even functions. So say you have say we have function say x square sine 2x. Okay, this is the function. Now this function, what happens? X square is the even function. This is the even function, and sine 2x is the odd function. Okay, so you have a f x square sine 2x. If I take f minus x, what will become minus x square sine minus 2x. This is x square and this is a minus sine 2x. So this is your minus of fx. So this is your multiplication of even odd will give you odd function. Similarly, let's take example, say we have an example, say x cube cos x. Now this is the odd function and this is the even function. So odd even should give you the odd function. Okay, so you have a fx x cube cos x. If I write f equal to minus x, that will become minus x cube cos minus x is positive, which is equal to fx. So this is the odd function. Okay, let me take some more examples. Say if I have a function, say 2x plus 3. Okay, and this is your sine of say 5x. This function. Now, if I take f is equal to minus x, this function will become minus 2x plus 3 minus sine of 5x. Okay. So this function is not equal to plus minus fx. That means this function is neither even or nor odd. So it's not necessary that function should be either even or odd. It can be neither even or neither odd. Okay. Now, say one more example I'll take. Say we have a function, say fx is equal to x4, say x4 plus 4, and then we have a sine x. Now, here, if I write f equal to minus x, okay, if I write f equal to minus x, so x4 will remain x4 and sine x will become minus sine x. So this become function will become odd function. Okay. Similarly, last say last I have x plus 2, say cos hyperbolic x. A function fx is equal to 1 upon x plus 2 cos hyperbolic x. Now if I write f minus x, so this will become minus x plus 2 cos of hyperbolic x. Now cos of hyperbolic x is the even function, but this function is a neither even neither not. So this function is also neither even nor odd. So this way we can identify the functions. Now what happens if your function is odd and even? Okay, what are the advantage we will get writing Fourier series when your function is either even or odd? So you see, integration means we are calculating the area. So if this function is even, now these both areas are same. Okay, So instead of integrating the series from minus pi to pi, what I can do, I can just integrate from 0 to pi and make it twice if the function is even. And so function is even. Now if you see here odd function, okay, odd function, the area above the x-axis is equal to area below the y-axis. So this is a negative area. So if I sum this to area minus pi to pi, this should become 0. Okay. So this greatly simplifies our Fourier series. जब भी function even या odd होगा, so what we can write? So if function is even or odd, in that case, Fourier series becomes simpler. They say function is even. Okay, if function is even, and now we know what is this is the series I'm writing in the interval minus pi to pi. Now here we know how do we define, we know a0 is 1 upon pi minus pi to pi fx dx. Okay, and an is defined 1 upon pi minus pi to pi fx cos of nx dx. Similarly, bn are given by 1 upon pi minus pi to pi fx sine of nx dx. Now, if functions become even, so this a naught I can write as a 2 upon pi 0 to pi fx dx. Similarly, an also can be written as a, I no need to integrate minus pi to pi. This can be written as a 2 upon pi 0 to pi fx cos nx dx, because this is the even, even into even function. So even function I can make it twice. Now, but if you see the bn, okay, this is the even function, this is the odd function, total is the odd function, so bn becomes 0 for the even function. That means my Fourier series gets simplified here. A0 simplifies where A0 A1 can be written like this. Similarly, if my function is odd, in that case, what will become? If function is odd, then my A0 will become 0. Okay. Here, function is even, Bn becomes 0. If function is odd, your A0 becomes 0. Similarly, your this fx is odd, even, odd. So your ans, that means total all an from 0 to infinite, they all become 0, and your Fourier series simplifies, and there has only bn terms. Okay, let us solve one problem showing this advantage of odd and even functions. Say we have this series function. Okay, this function is what? This function is say fx is equal to, the value is 4, between this is the minus pi by 2, this is the plus pi by 2, say. So minus pi by 2, so minus pi by 2 to plus pi by 2, this function has the value 4, and if function value is 0, when you have from minus pi to minus pi by 2, and function value is again 0 if you go from pi by 2 x to pi. This is a my function, and now this is the even function. This is the even function. Even function means Now I can only have to calculate A0, and so A0 will be my 2 upon pi 0 to pi. I need to only calculate here 0 to pi fx dx, fx dx. Okay, and this will be 2 upon pi. I can break here 0 to pi by 2, only higher value 4 dx, and pi by 2 pi 0. So only I need to solve this one. So this become 2 upon pi into 4. This become pi by 2 minus 0. So pi cancel. So this a naught value become 4. Similarly, if I calculate say an, so an will be again 2 by pi 0 to pi by 2, because pi by 2 function is 4, and now you have a cos of nx dx, fx pi by 2 pi function is 0. Okay, and now if I solve this thing, this gives me 2 upon pi into 4. Cos will give you sine nx upon n, 0 to pi by 2. So this value become 8 upon pi, and you have sine n pi by 2 upon n. Okay, so now my function become 4. Okay, so my function become what? My function becomes say fx a naught is 4, and an is 8 upon pi sine of n pi by 2 upon n. Okay, now if n is even, so my an will become 0 if my n is even. Okay, 0, if you put 2 3 2 4 5, 6, this will become 0. And now if n is odd, okay, then n will become my plus 8 upon pi n, pi 1 by n. Okay, if this value is say n equal to 1, 3 is become negative 5, then 9. If this is the values, this sine and pi by 2 will become 1. Okay, so sine and pi by 2 is 1 when n equal to 159, and an becomes minus 8 pi upon 1 upon n when my n is even में तो 0 ही है. N is your, this is 0 when n is your 0 2 4 6 3, and then you have a 7, then you have 11. In those case, this will become, term will become minus. Okay, so now I can write my series. So my series will become fx 4 plus 8 upon pi. First term is positive, so cos n is 1, cos 1 back. The second term is negative, so 8 by pi is already there, so this will become cos of 2x upon 2. Third term is 5, so this become plus 1 by 5 cos of 5x. Fourth term is negative cos 7x, so on. So this is my series for this even function. This is the answer. This is the series for this answer. So I'll stop here. In the next class, I will discuss half Fourier expansion, okay, or half series expansion. So how to write a function which is not clearly defined between minus pi to pi or minus L to L, but still we can convert or extend that function either in the form of odd or even, and we can write their Fourier series. So that is called half Fourier series expansion. We'll discuss that in the last class. I'll stop here. Thank you.